Hello and welcome back to the 310 notes. This is part 3. The first thing I want to talk about is inverse trig functions and what that means, okay? And so what I want to do is first just draw the picture of a triangle, okay, a right triangle. And I'm going to call this a right triangle here. I'm going to call this angle theta. I'm going to call this the opposite side, my hypotenuse, and the adjacent side, okay? And so, what an inverse trig, let's just talk about a regular trig function. If I were to say, say sine of some angle theta, okay, that's going to give me the opposite side divided by the hypotenuse, okay? Now, I want to denote that this is my angle, okay? This is my angle, and this is the ratio of sides, okay? So, but if I wanted to say, let's take the inverse of this, then I would say that sine inverse of the opposite side divided by the hypotenuse, then that gives me angle theta. Okay? So, and all I've done is just switch my values. Okay? This is my angle measure, and this is the ratio of sides. Okay? And so, if I have an inverse function, okay, this input is the ratio of sides, and I get my angle measure, okay? When we take sine of some angle measure, it gives us the ratio of sides, all right? So, when you were taking geometry, you use this all the time because you were finding angle measures given sides of a triangle, okay? And that's all you're really doing. So, I want to take a look at deriving the derivative formulas of inverse trig derivatives, okay? So I'm going to take a look at sine, or inverse sine, and what I want to do real quick is, given this this function here, okay, this inverse function, y equals sine inverse of x, I want to rewrite this using a regular trig formula, okay? Because the whole concept of this is to take the derivative, but I don't have a rule for this, okay? So let me rewrite this as x is equal to sine of y, okay? And all I'm doing is switching my x and y value, and now I have a regular trig function, okay? Now, what I want to look at here is a right triangle that kind of shows this information, okay? Sine of y. Y is my angle measure. So I'm going to put y right in here, okay? And then if I take sine of y, I get x. Well, this is really just x over 1, okay? So this is the opposite side divided by the hypotenuse, 1, okay? This is a right angle here. And so what we know, guys, is that I have a friend, okay? And that friend is Pythagoras, okay? And I can find this third side of my triangle here, okay? And if I think of this as a and c and b, okay, we know a squared plus b squared equals c squared. So if I wanted to find this length here, I would just take, x squared plus b squared is equal to 1. And if I solve for b, then I would get that b is equal to the square root of 1 minus x squared. Okay, I skipped a bunch of steps there, but that's the idea. So I'm going to call this length here the square root of 1 minus x squared. Okay, and we're going to need that later. All right, so I want to take a look at my my function here, x equals sine of y. Okay, and the whole point here is to find what dy dx is. Okay, what the derivative of my inverse function is. So if I took my derivative here with respect to x, okay, if I ddx this whole thing, so I'm going to take ddx of x, and I'm going to do ddx of sine of y, then the derivative with respect to x of x, since those variables are the same, is just 1, okay? And then if I take the derivative with respect to x of sine of y, I have to use implicit differentiation. I have to use the chain rule. So I'm going to get cosine of y times dy dx, okay? And then I can divide everything by cosine of y and divide by cosine of y. And so I get this. I get that the derivative with respect to x, derivative of y with respect to x, is equal to 1 over cosine of y. Well, let's think about something. What is cosine of y? Okay, and that would be my adjacent side divided by my hypotenuse. So as a result, okay, cosine of y, that's going to give me 1 over the square root of 1 minus x squared. Okay, and so my derivative is going to be 1 over square root of 1 minus x squared, okay? So that's the derivative of this, okay? So we can derive these, and we end up getting a formula here for that, okay? So now let's take a quick look over here at y equals cosine inverse of x, okay? And I'm going to do the exact same thing, okay? And so the first thing I'm going to do is I'm going to rewrite this as a regular function as x is equal to cosine of y, okay? And so given this example, given a trig function, I can draw a right triangle here, and I can write this as, here's my right angle, here's my angle y. Cosine of y is equal to x over 1, okay, the adjacent side over the hypotenuse. And by the Pythagorean theorem and kind of what we just did, we'll get the same thing for this length here, the opposite side, which is 1 minus x squared, okay? So what I want to do is I want to take the derivative here with respect to x, so d dx of x, okay, and that's equal to d dx of cosine of y, okay? And so let's evaluate this derivative. I'm going to get 1 here, and then I'm going to get the derivative of cosine. So derivative with respect to x of cosine of y, these are different. So I got to use the chain rule. I have to use implicit differentiation, and I'm going to take my normal derivative, which is negative sine of y, and then I'm going to multiply this by dy dx, okay? And so I'm going to divide everything by negative sine of y, divide by negative sine of y, and so I'm going to end up getting that dy dx is equal to negative 1 over sine of y. Well, now let's think about this. What's the sine of y? So here's my angle y. I take the opposite side over the hypotenuse, and that's going to end up giving me negative 1 over the square root of 1 minus x squared, okay? And so then let's write our rule here that dy dx, and I'm not going to write it there, I'm going to write it up here. Okay, that dy dx is equal to negative 1 over the square root of 1 minus x squared, okay? So this is pretty interesting, because it's very, very similar to what we just had, okay, over on this one. But what I notice is that, if I take the derivative of inverse sine, I get, this positive 1. And then if I take the derivative of inverse cosine, then we end up getting a negative. So it kind of follows the same rules that we had already had when it came to, the regular trig rules, how the derivatives of cofunctions are negative, okay? So I'm going to do one more. I'm going to do tangent. Okay, and tangent, I'm going to rewrite this whole thing as, I'm going to rewrite this as x is equal to tangent of y. Okay, I'm going to go off the page a little bit here. And so as a result, I'm going to draw the triangle, okay? And so here's my angle y. All right, and the opposite side, so tangent is opposite over adjacent, so that's going to be x over 1, okay? And if I wanted to find what what c was equal to, then that's just going to be, what do we got here? I know a squared plus b squared equals c squared. This is going to be 1 plus x squared. Okay? But it's also going to have the square root symbol. Okay? And I got that from, doing x squared plus 1 squared is equal to c squared, and then solving for c, I get the square root of 1 plus x squared. Okay, so now let's take the derivative with respect to x of over here, and I'm going to do ddx of x. Okay, and then I'm going to do ddx of tangent of y. Okay, so as a result, I'm going to get 1 here, and then over here I'm going to get secant squared of y times dy dx. Okay, and so I'm going to divide everything by secant squared of y, divide by secant squared of y. So as a result, I get dy dx is equal to 1 over secant squared of y. All right, and so if I'm thinking of secant of y, okay, let's just evaluate secant of y. That's really just 1 over cosine of y. Okay, and cosine of y is adjacent over the hypotenuse. So we're going to end up getting 1 over... So that's 1 over the square root of 1 plus x squared. Okay, so as a result, from that means I'm going to, 1 divided by that fraction, I'm going to multiply by the reciprocal. So secant of y, okay, is really just equal to the square root of 1 plus x squared. Okay, so what I want to do here is substitute this into my derivative here. Okay, so I'm going to end up getting dy dx is equal to 1 over the quantity, square root of 1 plus x squared, that quantity squared because I had secant squared, okay? And when I square a square root, all right, I'm going to get dy dx is equal to 1 over just 1 plus x squared, okay? And that's my derivative of inverse tangent, okay? I'm going to go ahead and stop this video, and we'll continue on with the next one. So we'll see you in a few. Thanks. Bye.